Hello, everyone. Welcome to this session of the community track. My name is Deepthi Sigireddy. I'm a software engineer with PlanetScale, and I'm also one of the maintainers of Vitess, which is a CNCF open source project. Our next talk is going to be on a Kubernetes application end-to-end DevStats. And let me introduce our speakers. This is Łukasz Gryglicki of CNCF. He's a senior software developer with CNCF and the primary developer on DevStats. And we also have Josh Berkus, who's the Kubernetes community manager at Red Hat. And he's active in the release and contributor experience 6 for Kubernetes.
Okay, well, thank you. Well, welcome. We've already been introduced, so you don't need that. But let me talk a little bit about why we're here. So a while ago, now we've actually had an issue open for a long time to better Kubernetify DevStats. But then a while ago, I was teaching some new people how to use Kubernetes properly, and I was like, hey, let me find a good example for you of a production application in Kubernetes, right? What that would look like, right? Something that's got deployment information and configuration and is set up to use some kind of CI/CD and has like a database and a UI and connection routing and maybe some other things like jobs and config maps, et cetera, and some way to deploy it, right? All of these things. And I looked. And I did some Google searches, and I looked in all of the Kubernetes and CNCF stuff, and I looked in people's Medium blogs, and what I found was Guestbook. How many people here have used the Guestbook sample app? Right, off of the Kubernetes sample apps, right? Great, so it's got a couple replica sets. It has a secret, and it has a couple services. And that's pretty much it. Doesn't have ingress, the database is non-persistent, there's no operator or Helm or any other way that you would actually deploy this as an app. There aren't any jobs, cron jobs, there's no CI/CD. It's not current for 1.13, which is when we started working on this, certainly not current for 1.14 or 1.15 now. Nothing is SSL. It's definitely miles away from being an example production application, designed to be as simple as possible. So when we actually started work on making DevStats completely a Kubernetes application, we're like, let's not just make this a Kubernetes application, let's make this an example Kubernetes application. Because it's open source from top to bottom, so we don't have any limitations for what we can put out there in GitHub for people to look at. So before we actually go into the details of what that looks like, let's actually explain what DevStats is so you'll understand what the parts of this application do.
So the DevStats is a CNCF created tool. That's main reason for it is to analyze contributions and development process across the CNCF projects. So it uses 3 different data sources. One of them is GitHub archives, which are just a way of store our GitHub activity using BigQuery and using our GitHub events. We also use Git for a storage to analyze files in Git. And finally, we use GitHub API to see if our data is correct. It uses Grafana as a UI, and also, you can just take a look at how it looks like.
Yeah, so I mean, it's here. This is the thing that I and some of the other community managers use all the time to find out how the Kubernetes community is doing. It's also available for other communities. And so we have a whole large set of different dashboards for community information. Like, for example, an important one to us is one called PR time to engagement, which is that if somebody submits a brand new PR, how long does it take to get the first response from a human? How long does it take before it actually gets reviewed? And how long does it take until it gets merged or rejected, right? Because if that amount of time starts going up, then we have a problem. And lots of other charts like that.
And so across the 2 years old DevStats project, It initially was created to track CNCF project, but after some time, some other foundations also joined, so like, for example, continuous delivery and so on. And every single foundation can have its own DevStats instance, and it can have multiple projects, tracking across multiple GitHub orgs or things like that. So,
yeah, so we'll get into that. So we had, but basically, so then we went through an experience that I think a lot of you either have gone through or are going through. How many people here are looking at moving a monolithic application to a bunch of Kubernetes microservices? And how many people have already done it? Yeah. So this is a familiar experience, right? And again, we have the opportunity here to do this in sort of an example way, right? So our old setup was a couple of packet servers.
Yeah. So our old setup that is currently still running is using 2 powerful packetnet servers, which are quite powerful, as I said. So there's 38-core processor, there are 200 gigabytes of memory, there are 6 mirror SSD disks, and so on. We are using Apache proxy, we are using Let's Encrypt, and basically it's starting to become a problem because we need to update all these tools when, for example, new version of Ubuntu comes, then we need to just install everything from scratch. So
yeah. And so then a few weeks ago, a friend of mine, Michael Rogers, who I know from the CouchDB days, pinged me and was like, hey, we actually want to run DevStats for our open source projects. How do I install it? And my answer for that is, well, that's kind of complicated right now. And it would be really nice to make it a little bit less complicated. On top of which,
yeah, so we created this example for the purpose of this KubeCon talk, but during doing so, another foundation, GraphQL, wanted their own DevStats instance. And basically, while developing instance for this talk, we used exactly the same approach, and actually it's already running in production on Kubernetes.
Yeah, I've got that right here.
In the meantime,
here we go. Here's the GraphQL
yeah,
DevStats.
And also in the meantime, many other projects asked us for creating their own DevStats instance, for instance, Kubeflow, HTO, and Linux Foundation is also considering running this internally as a data source. So it's a lot of other projects that need to be ported.
Yeah. And then, of course, we do work either with or for the CNCF. And so, kind of need to be not running a monolithic app. We need to run this on Kubernetes anyway. It was built before that was really a reasonable thing to do, but now need to actually do that. So there were a few steps involved.
Yeah, so basically we needed to, the biggest problem to solve was how to store our data. So we needed to switch from local storage to some cloud provider. In our case, we chose AWS, just for this example, but we're trying to avoid any cloud lock. So basically, it can be used with Google Cloud, with anything. So we use EBS volumes. We Dockerized every part of DevStats. So we have DevStats image, we have Grafana image, we have cron job image, we have image for tests. We replaced local Postgres with our solution Patroni, which is a high availability database cluster on 3 nodes currently. We created a separate services for read-only access and for read-write access to take advantage of read replication. And finally, we used Helm for template everything and to allow adding any new projects in a very easy way in just a single YAML file, and it will just generate templates, Kubernetes manifest for every project.
Now, I did run into a couple of problems in the course of making this work.
Yeah. So basically, the biggest problem was with Docker, which was limiting shared memory available for pod to 64 megabytes. So this is obviously a very low value for a database. So we did a trick that's also used by OpenShift. We mounted a memory volume under the dev.shm directory, which basically gives pod access to entire RAM. Of course, we are using limits and requests limitation Kubernetes on every pod to not allow, for example, nodes to be killed by too much RAM usage. Yeah, but basically another problem was with permissions related to storage, because cloud provider, in this case AWS, mounts our disk with root access, while the Postgres database runs as a Postgres user. So we needed to handle that by patching Patroni installation and also by running the container in special FS group mode for the Postgres user.
And also, so one of the other things is we used to have 2 big PacketNet servers, and we actually needed to split that out into more separate nodes in order to have, say, 3 nodes of redundancy for Postgres, other redundancy for other things. And the final thing was, for both of us, this was actually our first production application on EKS, and there was a little bit of a learning curve there. There are just some things that Amazon assumes that you know about the AWS environment that you don't necessarily know if you haven't done it before, or even in my case, if you simply haven't deployed a production application in AWS in a couple of years. So we ran into and had to solve those. So it's now ported over. So, and because we wanted to show you this example app, let's talk a little bit about what we have in there, right? So like I said, we wanted to give examples of most of the things that you would need for a production Kubernetes application, because we actually need most of these things, right? So that includes ingress for access to things, multiple services, a stateful set, a replica set, actually multiple replica sets in a production deployment, volumes, cron jobs, secrets, SSL certificates, Helm, which is what we use for deployment, RBAC for setting some special permissions, and also tests for the whole platform. The technologies involved include Ingress ELB and then NJNS Ingress for the Ingress solution, using the AWS cloud provider in this installation, of course, because we're on EKS, Grafana, Postgres, Travis CI for CI update, GitHub, Docker Hub, AWS, and then the wonderful Let's Encrypt certificate manager we'll talk about more in a minute. This is a very simple version of what the general application structure is, right? So the idea here is, on the left, we have contributions coming into projects via Git and GitHub. We then take a whole bunch of contribution information, we put it into a Postgres database where we massage it into an analytics format. That is then displayed via Grafana, which people access through an NJNX Ingress access in the front end. Also in the back end, changes to the data structure and the generated reports come from GitHub, and Travis CI tests them, and then we can deploy them to Postgres. So that's sort of our basic application structure. There's a bunch of refinement in this. Again, we'll get more into that.
Yeah.
This lives in 3 different repositories, so.
Yes, DevStats initially was one big repository, but after time we've seen that there are many different deployment modes like bare metal, Kubernetes, Helm, and so on. So we divided it into containers repo. It contains Docker images for every single part, like provisioning image that is needed, that is started only once to provision all data, our listing cron job image, tests image that build other image and executes tests on GitOps using Travis CI, Grafana image, and finally Patroni Database image. Another is a charts repo. Charts repo is where the Helm chart lives. When chart lives, it defines all the loops to deploy all projects defined here. And finally, we have a DevStats repo. This is the old repo where all the code was used to live. It's split in 2 parts right now. One is just the source code needed to build, and another one is deployment-related stuff that can be used for bare metal deployments and other things like that.
Okay. So, like I said, we're using Helm for deployment right now. One of the things that I'll warn you is when you look at the actual Helm charts, you're going to find that they are a little bit complicated. Let me show you the Postgres portion of the example. Is both, there's a bunch of exception code in there to allow you to swap out specific components. Because like one of the things we wanted the ability to do is decide between hosting our own Postgres and using something like RDS, because we were on the fence about that. Hosting our own Postgres worked great, and we decided to stick with that, but we wanted to be able to swap back out. There's also a bunch of loop code in there for the Grafana builders, because we have a separate Grafana pod for each different project whose stats get displayed. And for that reason, we generate a whole bunch of them. And that all is done through looping code in the Helm templates. So just in the case of when you actually look at the Helm source code itself, it's going to be a little hard to read for those reasons. So, deployment platform that we're on top of, right now Kubernetes 112, because we're on EKS, and that's what EKS has, is Kubernetes 112. It's designed to be fully portable though, because we don't necessarily want to be tied to a specific cloud. The main reason for doing EKS were, familiarity with AWS otherwise. We had a bunch of free EKS credits, did come into that. Yeah. And then finally, in the case of why we would want a major cloud provider to begin with is just that it was a much easier way for us to handle storage and load balancing, right? It's because the cloud provider provide those, whereas otherwise you have to do something like, SAN or Ceph plus IPVS in order to have those. However, we are looking at potentially moving back to a more bare metal installation.
Yes, exactly. We just needed an example for KubeCon tag, so we don't have enough time to create a full bare metal deployment, but our aim is to, for example, we can even reuse our current bare metal servers that are serving DevStats right now. We can make them 2 nodes, for example, and just take another few PacketNet servers to create a fully bare metal deployment. Of course, the problem will be with egress and with the storage, but we would probably use local storage for this case.
Yeah. So let's talk about some components here. And I'm going to be flipping back and forth because we have a whole lot of YAML here. So here is the PV setup. This is actually the Helm template. I'll be showing you some Helm templates and some generated files, depending on which component it is. But this is the Helm template for the various PVs in here. Because they're pretty generic since we're using cloud storage.
Yeah, so this is every single project needs a storage for Git clones, because in addition to GitHub events, we are also analyzing particular commit files. So you can, so every single project needs its own persistent volume claim for Git storage. So this is why we have it. We also have free provision, free persistent volumes for Patroni Database, 1 for master and 2 for slave nodes.
Yeah, so speaking of the database, for those of you who aren't familiar with Patroni and the setup and that sort of thing this is a Kubernetes-based, fully automated HA setup for Postgres, where you have one master node and any number of read replicas at a given time with automated leader election so that you can fail over. And then that attaches to 1 PV per each individual Patroni node, and we have 3 in the sort of default setup. So this includes a stateful set for Postgres, and let me actually just show you that instead. So here's the here's the stateful set, and basically it's your pretty straightforward general stateful set. That pulls in there. The one thing that you actually see in the generated files is there's a whole bunch of command arguments, which are all Patroni and Postgres configuration variables that all go in there in order to configure it via Helm variables. But the only sort of weird thing we had to do here was both file system configuration, group access, and then setting up shared memory as a volume, like we mentioned earlier. There are a couple of dependencies in this, which actually I think I can show you in here. Yeah, this is why I'm using the template, so I can actually show you the dependencies, because the generated files, it's 1 per object. So we've got a couple of services, obviously. We've got the master service, and then we have the read-only replica service that we use for the public portion of the application. And then there's also some RBAC stuff, because in order to control failover automatically, Patroni manipulates Kubernetes endpoints, which is an object type that you don't often talk about because it's generally implicitly created by a Kubernetes service, but you can't actually explicitly manipulate it, as we do for Patroni, in order to make sure that the connection to the master always goes to whoever is the current master, and thus prevents us from having split brain. And so you'll see in there granting Patroni the ability to create and manipulate both config maps and endpoints. Now, the data actually comes from a variety of sources.
Yeah. As I mentioned at the beginning, there are Git, GitHub Archives, and GitHub API. All this data is checked and updated every hour by the Kubernetes cron job. And it then ran a bunch of metric time series generating program that also saved this data into Postgres database, because we are using Postgres as a time series database. And finally, this data got displayed from Grafana using read replications. There are more than one replicas of Grafana, even for single project, and they just can take advantage of our high availability of the database.
Yeah, and so that's called in a Kubernetes cron job. So we've got a cron job object in there that pulls the hourly sync image with, again, a whole bunch of variables in there in order to do it. Yeah, we already talked about that.
Okay, so Grafana, we were not able to use the standard Grafana installation because we have a lot of custom changes to Grafana, so we decided to create DevStats Grafana image that provision itself from a set of template variables like database access, like dashboards, JSONs that needs to be displayed, and we are also customizing some artwork like icons and links and things so on. So this is how Grafana is created. And if you want to add another dashboard, you are just updating the image, and the Kubernetes will fire the rolling update, and a new Grafana will be available once it's finished.
Yeah, and as I mentioned, we get a separate Grafana pod for each hosted project, for each project whose community stats are going to be displayed. And for that reason, if you actually look at the generated files from Helm, what you'll see is a whole series of deployments here. Like in this case, this is for the Prometheus project. Are we doing more than one here, or is it just Prometheus? We just did Prometheus.
Yes, because
but it's labeled, right, it's labeled Prometheus in there. But if you were actually hosting 5 or 6 different projects, you would see 5 or 6 different replica sets there.
Yeah, so the secret files, we came easy with that one. We don't have any fancy secret management right now. We just have a bunch of files ending with .secret that are not checked into the repo, and we have corresponding files ending with example. So before you actually can install the Helm chart, you need to take the example files, and for each of them you need to provide your own values. They are just they are used internal by the cluster, but you need, for example, provide GitHub API case and passwords for Grafana, for Postgres, and so on.
Yeah, and then it'll generate the actual secrets calls for populating those.
Engine ingress controller. We are using Nginx to route traffic to a specific Grafana instance. We are registering a domain with wildcard domain. So, for example, we have DevStats demo.net, and every single subdomain from this is routed to our AWS ELB endpoint, and that endpoint is used by the Nginx, and Nginx takes a look what is your host name, what is your subdomain name, and based off that, it directs the traffic to a specific project's Grafana. We are also using Cert Manager, which is a very good program. Once you have a domain name, you can use it to automatically use Let's Encrypt and automatically renew all certificates. Yeah, so also testing. So testing is not yet finished, but the CI part is ready. So we have Travis' job that is fired on GitOps. And on every GitOps, we are building images and building test image that is executing the tests and returning the final state. We are missing the continuous deployment part. It was implemented on the bare metal solution, but right now, but our solution was not good enough for Kubernetes, so we are considering to switch possibly to some other CI/CD environment, but it's not ready yet.
Yeah, so in case any of you actually want to deploy DevStats itself, which you might if you're involved with other open source projects and that sort of thing, just a few notes on actually running it in production, what you would actually need to do to take the code that we have in order to run it in production.
Yeah, so first thing you need to do is to have some domain registered. We used AWS Route 53 for our example, but it can be anything. Then you need to have some ingress controller. In our case, it was ELB from AWS. And finally, you need something to handle certificates. In our case, we used open source programs Cert Manager. That uses Let's Encrypt under the hood.
Yeah, now one of the things that it is set up for, and like I said, the reason for some of those complicated Helm charts was it was designed to be a somewhat flexible deployment. I mean, honestly, it was because we wanted to be able to change our minds in the future about exactly how this was installed and where it was installed. So including things like, if you don't feel comfortable running a self-hosted database, then you might want to swap it out for RDS or DigitalOcean, Postgres, or whatever else is available on your platform. And so you can do that. You might not want to use Grafana if your goal is to just generate analytics data that is going to be consumed by some platform other than Grafana. It's also set up to do that, including output to Elasticsearch as another option. Yeah,
so we had some requests to create a special instance for DevStats, and that instance was, for example, using Aurora DB. So this is a managed Postgres solution. It wasn't using Grafana at all, and it was using Elasticsearch as a final store for data from DevStats.
Yep. So, still work in progress. Stuff that you are welcome to submit stuff to contribute to. Obviously, number one thing is documentation. You know, to some degree, these charts and stuff are supposed to be self-documenting, but nothing is really self-documenting, so we need to actually write up the purposes of all of the components and how they work internally, et cetera. We need to register the Helm chart on Quay.io or another service so that you can install it without a Git clone. Doesn't currently have any monitoring built in. That's another major sort of, you know, production application example thing. And so we need to at least have some basic monitoring in there via Prometheus or otherwise. Because I work for Red Hat, I'm also going to create an example operator out of this using the operator development kit, talking about doing improved CI/CD in here. And then maybe look at having a more sophisticated solution for secrets management, you know, Vault or otherwise.
And one thing that is sure for now, we are moving our current deployment for all CNCF projects from bare metal to Kubernetes. So it's not yet decided if we will use AWS or we will go just bare metal. I think we will go with the latter, but we will see.
Yep, and then of course the big thing is, we're really interested in people who are interested in contributing to this. We're interested in using DevStats. We're interested in contributing to it either as DevStats, because you want the community stats and the development stats, or as an example application, right? If you want to say, hey, I don't actually care about DevStats, but I do care about secrets management, so I want to have this robust implementation of secrets management as an example to new Kubernetes users, we would love to have that, because there's some things we probably won't get around to doing because we don't actually need them in production. So given that, we actually have, you know, 7-8 minutes for some questions. Here's links to all of the repos and everything else. So do you have questions? Yeah. So his question was the experience of decomposing the monolithic application into a bunch of services, and talking specifically about having a lot, like hundreds of services. I don't think the original application was that complicated.
Yeah, so the funny part is that this application was created by CNCF, and CNCF is a home for Kubernetes. So since the real beginning, I was considering Kubernetes as a final platform. So we, of course, needed to split a bit of parts, but basically the main DevStats was built with Kubernetes in mind since the real beginning. So, for example, every single binary, like binary for data sources, like binary that is calculating metrics and all other stuff, they were all separate, and they were communicating through the database service that was also configurable from the real beginning by the environment variables. So it wasn't that hard because that was the final target from the since beginning. Yeah, so.
Yeah. So the question was how we assign specific contribution, both in terms of how do we know who contributed something, and then asking about the company attribution of contributions.
So we have a separate CNCF project, which is CNCF Git DM, or Git data mine. And this one is trying to get a big list of people and their company affiliations they were working for. So, for example, for single GitHub user, we can have a list of companies and the data ranges they were working for a given company for. This is all the manual process. We were trying automatic tools. There are a lot of them. And our outcome from this is that they help a bit, but we also get a lot of noise and trash that we need to manually filter. Currently, there is a contractor that is working only on this part. So we are constantly researching using LinkedIn, Facebook, Google, Twitter, wherever, and trying to find affiliations. And finally, we are importing the big JSON file with those affiliations about twice per month and updating data.
Okay, there was another question? Go ahead. Okay, so the question was how we deal with GDPR and whether or not somebody wants to be delisted. That has not been our problem so far. Well, the first part of GDPR, right, privacy has not been our problem because the data sources we draw from are all already public, right? We're drawing from GitHub where the information that we're drawing is already public. The second part of it, which is the right of removal, theoretically, we're prepared to effectively anonymize somebody in the database. So far, we haven't had to do it, as far as I know. We haven't had anybody. We did?
Yeah. So
okay.
There was a problem with GDPR, but our solution was exactly like Josh said. This data is public, so we don't need to hide this. But some people may want their data not to show. And we have a separate section in documentation. How can you create a pull request that requests removal of your data? And we have a special binary program that will scan our data and remove that, replacing this with some special marker that we don't have that data. So we actually have 1 or 2 cases of people asked us for remove their affiliation data from CNCF Git DM, and we just did that, and that's it.
So what was the hardest part in moving everything to Kubernetes?
Well, that will again be a strange answer. I don't think we have a hard part. It was a big fun for me. I am actually so amazed how Kubernetes make everything easier for me. For example, I don't need to care for an operating system anymore. I don't need to care about, in this case, storage. and many other things. So for example, when deploying new dashboards, I don't need to stop Grafana. I am just creating a rolling update which creates another one. And because it was written since the real beginning in Kubernetes in mind, I didn't really have biggest problem other than these two small issues with shared memory and permissions. Everything other was just good for me.
Any more questions?
And the hardest part. The hardest part of all of this, I think, is database management and persistent volumes for stateful application. But it wasn't hard at all for me, but if I need to choose the hardest part, this was it.
So we have one there and one here, and then I think we'll be done. Yeah. So one there?
How big a box do I need to run a test deployment of DevStats locally?
So how big of a box do you need to run a test deployment of DevStats? Well, if you don't want, how much memory would we need?
Memory?
Yeah, it wouldn't be big. I mean, I think honestly something like in M3 extra large or M4 extra large instance would be enough for a test run.
Actually, it depends on the project. That's the best answer, I think, because if you want to deploy Kubernetes, which has 300 repos and millions of events, you will need a lot of memory. But if you want to deploy something small, you will just be fine with a single machine EC2 default instance, I think.
Okay. And then last question.
A connection pool for database, you mean?
Yeah. We're not actually doing connection pooling. Because we have a separate Grafana prod for every project. Because they're pooling those connections for that, right. That hasn't been an issue. I would inject a PG bouncer pod in there if it became an issue. But so far, we never actually have more than like 100 simultaneous connections, which is easily handled just through the Postgres default.
Yes, and our bare metal deployment, actually I needed to tweak few Postgres variables like maximum connections, shard buffers and things like that, but our bare metal server is a beast, beefy, so powerful that even Kubernetes, it's not a problem for it.
Okay. So thank you very much.
Thank you.